Welcome to SQL for Data Analysts, but really, this is SQL for everyone. We're going to cover everything from the absolute fundamentals, downloading and setting up databases, to making sure that you understand select statements, various clauses, advanced aggregations. We'll look into common table expressions, joins, and more. So whether you're someone who's a complete beginner to SQL, looking to prepare for that next role, or you're someone with a bit more skills, looking to polish them up, this is the place for you. We're going to give you everything we've used here, all the data, all the queries, and a step-by-step guide telling you exactly how to do everything we've spoken about. And with that said, let's get into the video. Now let's start with the basics. What is a database? A database is an organized collection of data that can be easily accessed and managed. And there's two types. Relational, which is what we'll focus on today, where data is organized into tables with rows and columns like an Excel sheet, and they're related through keys. There's also non-relational databases. Now, as we just mentioned, inside database or a relational database, there are the tables with rows or records and columns or fields. Now, within these databases, there are different types. There are different database management systems. Now, a database management system allows you to interact with the database. Popular systems include Postgres, which we'll use today, MySQL or Microsoft SQL Server, and Oracle. It's important to bear in mind that SQL stands for Structured Query Language, meaning it does deal with structured databases and it's used to query the data. It is the standard language for interacting with relational databases and running crude commands, meaning it can create, read, update, and delete. These are the four basic operations performed on data in a database. Now, I'm going to give you a quick overview of each category of SQL command. They're all on screen now. There's DDL, DML, DCL, TCL, and DQL. They all cover different things like data control or manipulation, but don't worry about that too much. First of all, we're going to want to set up the environment. So you can follow along on my website and find all the notes today, absolutely everything. But before we get ahead of ourselves, let's go on and click this link. Now, when I'm referring to my website, what I mean is this here. This is my data science website where we have helped over 50,000 learners reach their dream careers in weeks and months, not years. Here we have workbooks in Python, and in that gap there, that's where we're going to add the SQL workbook today. All the notes, everything. I recommend checking it out. Anyway, make sure you head over to Postgres. On their website, click the operating system, which represents the device you are on currently. For me, it's Windows. I'll hit download and then select the most recent version. At the moment, it's 16.4. So I'll go along and again press Windows. Once that's downloaded, and it will take a moment, you want to run it. Go through each of these steps. It shouldn't be too difficult, just pressing next and next again. It will prompt you to create a password. Don't worry about it, just make sure it's something you can remember. So once I have typed that in here, it's then going to ask me to press next a few more times before you'll finally be done. Now, I recommend following along with me here. So if you need to pause the video at any time, don't worry about it. You can play whenever you need. Once you press finish, it'll take you to this screen here. Now, you can install one of these. Let's just skip that by hitting cancel. Yes, we're sure. So now if we head down and go to PG admin, we can open that. And let's do this again here. It's going to ask for a password, or at least it should do. Here we go. So let's just set one up again. So once that's done, it'll take you to this screen here. You can see if I drop down on databases, it's already created us one called Postgres. But let's ignore that for now and right click to create a database and give it a name. Here I'll put tutorial. Clicking in the SQL tab though, you can see the actual query it's running to create that. But we don't have to worry about that. right now. So if we save that, you can see very quickly on the left-hand side pane, it will update. Let's get rid of the Postgres and expand the tutorial by right-clicking on it and creating a script. So let's delete this for now and get right into the tutorial. Now we can get to creating a table within that database. Now the database is just the container for the different tables. And to do that, you simply type create table. SQL is very straightforward like that. So let's type. Now, just to point out, you can type it like this. SQL is made up of keywords, meaning there are different keywords used to run commands, and they don't matter the case you put them in, i.e. they are not case sensitive. So you could write this, or you could write this, or even this. But it is common convention to write all keywords which highlight in different colors in uppercase. So let's do that here. Create table and then the name of it. We're going to call it employees. If you hit the bracket, it's going to actually put 2 for you, which is great. We can hit enter a few times to type in the information about our employees. Now, first of all, I want the employee ID. And I'm going to assign it the data type serial and set it to be the primary key. Next, we've got first name. So first underscore name. And we're going to set that to a varchar, with a limit of 50, comma, and so forth. Now, exactly what each of these mean, don't worry, I'll get to that in a second. What I'll do first is just copy in what I wrote previously. It will speed things up. So we've got the employee ID, which is the primary key, the first name, last name, the hire date, the salary, department ID. These are all the different names of columns in the table called employees, which is wrapped inside these brackets. And also it's common convention to finish with a semicolon. Now, in different types of relational database management systems, they may not require you to finish with a semicolon, but it's just convention to do that. So let's hit run. You could also use F5. Now that we've run this, and make sure you did actually create the table from the database you're using. If you head down to schemas, and then down to tables, it'll be there. It won't be first of all, you'll have to refresh it, but I've already done that. So now we have our table. Now for a quick overview on the different types of data that you have in a SQL database, you have integers. Now these are whole numbers. Same as in Python, if you're familiar with that. Serial, now this is data type stored in a sequential integer. So this will automatically assign to an increasing number of rows. This one here is varchar. Now, if it was to char, that means it stores a fixed length up to however many you put here. Varchar is a variable length, so you can use as many letters as you want in the string up to this many here. So here a max of 50. There's also dates, which we have used. This will store date values as year, month, or day. And Boolean, which will store values as true or false. Equally, there's numeric. Now, numeric will store precise numbers with fixed decimal places. It's like a float point in Python. Now, you may note there's this primary key, and you could wonder what that is. Now, a primary key uniquely identifies each record or row in the table, and it relates to another table which will have a foreign key. Now, primary key is a unique identifier. A foreign key is a column which refers back to the primary key, establishing that relationship. So we've created one table here. Let me just call this one employees by leaving some comments. You leave comments by doing dash dash. Anything following a dash dash will not be registered as code in SQL. So now we've done that, I just want to create a departments table. So very similar again. In fact, the exact same. It's create table, these keywords. departments inside these brackets here and finished with a semicolon. We've got the name of the table, the data type, and name of the table and the data type. So here in the departments table, we have department ID and department name. Now, I don't want to run this all again because I've just run this once. So I'm just going to select the bit I want to run and head over, either pressing F5 or executing. Then again, if I refresh here, you can see we have both tables. Fantastic. Now this is great. We have tables, but there's nothing in them. So we want to insert data into it. And to insert data into it, well, you use insert into. So I want to insert into departments. Now in the department name column, I want to do the values of human resources, finance, engineering, and sales. Again, it's very similar in how you write each of these queries. You don't have to put them on different lines. They could all be one line, they could be separated like this. That would all be fine. This is all just for readability in the same way that you capitalize these keywords and that you finish each with a semicolon. But let's hit run. And I also want to insert data in the same way into the employees table. So again, I will hit run. And now that we have that, and again, all of this will be included on my website. So if you want all the notes or you're struggling to follow along, don't worry because it's all there. Now that we have all of this, it's important to cover a topic known as constraints. These are something that enforce rules on the data in the table. For example, primary key. That was a constraint that we put after the data type. This ensures the uniqueness of each record. It means it can't be null or duplicated. Foreign key would be another one, ensuring it enforces referential integrity. There's other ones too, like not null, just like that. And what that would do is ensure that a column cannot have any null values. Unique is similar, but it ensures all values in a column are unique. Another key topic is normalization and denormalization. Now, normalization is the process of organizing a database to reduce redundancy, making sure there's no duplicate data. This improves data integrity, accuracy, and consistency. So effectively, you're dividing the data into related tables, as we've done here. And you want to get it down to its maximum normal form. Now, normal forms go from first to fifth and are the levels of database design guidelines that progressively reduce redundancy. You want to get it to its most normal form. Denormalization is the opposite. It is combining tables or adding redundancy intentionally that may just enhance the read performance or simplify a query. Equally, you can have something called an entity relationship diagram, an ERD. This is a visual representation of the relationships in the database. Now, the way you relate tables is in one of a few ways. You can have a one-to-one record. You can have one-to-one relationship where one record in one table directly relates to one record in another. One-to-many, where one record in a table is related to multiple records or many in another table. Or many-to-many, where many records in one table relate to many records in another. This is often the case in a junction table. But now we've got all of that out of the way, let's begin with some basic SQL queries. The first, most basic query you want to do is select. Now, a select statement is used to retrieve data from one or more tables. So again, let's type that in uppercase. We want to select, and then we're going to type asterisk. That stands for everything. Select everything from, and then the name of the table, employees, and we'll finish that with a semicolon. Let's hit run. And down here, you'll see it successfully ran in 175 milliseconds with 5 rows affected. These are all the different columns with their names, their data types, and all of their values here too. So we can do the same thing, but for specific columns. So let's say I only want to pull the first name and last name. Say I work as a data analyst at the company and they go, hey, we need all the first names and last names of all employees who work here. Well, that's fine. Instead of everything, let's delete that. We just type first name, comma, last name. Hit run. And now it will return just those two fields. Equally, we can introduce where clauses. These are conditions. A where clause will filter the records based on that condition. So let's say we want to find employees with a salary greater than 50,000. So to do that, we will select first name and last name from employees, where salary, which was another one of our columns, is greater than 50,000. Let's finish that with a semicolon and hit run. And here we go. Here are all of our employees who are earning greater than 50,000. To demonstrate that a little bit better, let's also add the salary column. And you can see that's the case here. Now, there are different operators you can use. This is a comparison operator saying greater than. There's also less than, greater than, or equal to. You can use logic operators. So you could say where this is the case and something else is the case. So for example, what we're going to want to do here is let's copy and paste this in and explain it. I want to select first name, last name, hire date, and salary from employees where the hire date is greater than 2020, the 1st of January, and salary is greater than 50,000. If we hit run, these are the two employees that we have which meet that condition, John Doe and Emily Davis. So there you go. We're already off to a fantastic start. You've set up a database, you've installed SQL, you're using Postgres, and you're aware of the fundamental concepts. But what if you wanted to order this data? Well, you can imagine if you want to order by something, you just type order by. So here's an example. I want to select first name, last name, hire date from employees, and order by hire date in descending order. Now this DESC is the code for descending. If you don't type that, by default, it will be in ascending order. So just rerun that here. And there we go. So let me show you that here. This is by hire date, so it's from 22 onwards. If we delete that and just hit run again, you'll see it's from ascending order. You can also limit results. Now, the way you do this, again, is different between different systems. We're here using Postgres, which means it's quite easy. You can just type limit. So as an example, if I wanted to select the first name, last name, salary from the employees table and ordered by salary descending, I could then limit it to the first 3 records. Here we go. 1, 2, and 3. Very easy, just using that keyword limit. You can see now that SQL is a series of keywords referencing tables and columns within those tables with different constraints and conditions. It's not too complex, at least not at this stage. Sometimes I want to get unique values, and to get that, for example, finding the distinct department IDs, I would use select distinct. So select distinct department ID from employees. And now you can see this is how many there are. You could sum these up or count them. That's called an aggregation, and we will get to that later. That's good for quick ad hoc analysis if someone quickly wants to ask you as the data analyst at an organization, hey, how many people do we have working here in this department who earn more than this amount and started at this date? Well, you can see now how you could very quickly run that in SQL. If I was to export this out, if I was to give this data to someone and say, here you go, this is the result, they might go, that's not a great column header. Well, how do we fix that? We can use aliases, where we give a table or column a temporary name. So let's select the first name, which is first underscore name, as you can see here. first underscore name, but let's select it as first name inside these quotation marks, last name as last name, and salary as annual salary from employees. When we run this, it gives a lot clearer look to our data, meaning you can understand it a lot better. Now, we had mentioned before aggregations. So let's say I wanted to look at the average salary and I wanted to alias that as average salary. Well, to do that, this would be the structure I'd use. Select AVG, that's average, salary, the name of the column. I'll alias it within those quotation marks, and then state the table I want to pull it from. So this is the average salary here. Now that's average. What if we wanted to count? Well, we would write count here for the aggregation keyword. We would select the count of everything, remember asterisk, and we'll run this. So total employees from employees, there are 5 in total. Now, as a quick interject, 1 to break up the video, but 2 to make sure you're getting the most value from this video, I want to talk about W3 schools. There's a lot on here which we've spoken about. We should cover everything here in this video and the workbook. But let's go through some points specifically here. Now, a wildcard is a character we can use to substitute other characters in a string. The percent one, as you could see, could show that you want anything after that point. So we could have %, a few letters, %, meaning anything within a string that has those values. You could do underscore, showing that any character can go there as long as it fits the overall pattern. There's lots of great stuff here. I highly recommend checking it out. Now, if we look further into this, you'll also see they have in. In is a operator for a shorthand in a where clause. It allows you to write quicker, shorter, more efficient queries. For example, where price is between these two values. Union is another great one. It's an operator used to join data horizontally rather than vertically like in a join clause, which we will cover later. It just stacks a table on top of another table. But anyway, back to the workflow. Now, if we get a little bit more complex, we might want to group our data together, grouping similar rows that have the same values. And to do that, we use something called group by. So we would select the department ID. Let's say we will also want an aggregation, so the department ID, the sum of salary, which we will alias as total salary. We want to pull that from the employees table, and then we want to group it all by the department ID. And again, finishing with that semicolon. So you can see now that for each of the department IDs, we get the total salary. We could also order that as well. So let's write that here. Order by the sum of salary. Let's copy this here. And let's do descending. Or we can equally do it ascending as well. So there we go. We can see that the department 3, or that ID, earns the most salary on average. Now, when you're using a group by, you can't then add a where on it. You can't group by this and then say where department ID equals 3. It won't work. And you can see it's underlined that here. When you've used a group by, you then have to use a different keyword called having. So let me demonstrate that here. I want to select department ID, run an aggregation where I sum the salary and alias it as total salary. I want to pull that from employees. I want to group it by department ID. Having sum of salary is greater than. So if I run this, it will work. If I write where, it won't work. That's just the case. It's just something to bear in mind. It's not a major thing. Just again, do bear that in mind. Now that's great. That was a single query and we've run quite a few now. But what if I wanted to run multiple queries and nest them inside each other?
a nested query, or more commonly known as a subquery. So let's do that to find employees who earn more than the average salary. So to do that, you would just select the employee details, first name, last name, and salary from the table where salary is greater than. And then within that greater than, you could put yet another query inside brackets. So I want something that's greater than the average salary selected from the employees table. So I hope that makes sense. This is a query, and here's a subquery within that wider query. And if I run it here, you can see, there we go. It's successfully run. Now, we did mention earlier that we had some date values in there, and it's important to know how to work with dates. So if you write the select keyword followed by now, this will tell you the current date. This is the date and time right now as I'm recording this, time zone and all. You might want to extract a value from this. You can see this is a timestamp. This isn't very readable. It's not ideal. If we take a look at our employees table, let's select everything from employees. You can see I have this higher date. And this is a little bit more readable, but maybe I just want the month from it, or just the year from it as its own output. Well, to do that, I would do extract. So as with everything we've covered so far, with all queries, we start with select. And we use select, extract, and then within brackets, year from the column name. And we alias it as year. We also want to extract, so select extract month from hire date, in brackets, aliased as month. And we also want to select extract day from hire date and alias that as day from employees. Let's put this all within here, just like that as well. And then when we run it, you can see we have the year, month, and also the day. That's actually quite useful, but what if I wanted to use some date arithmetic or calculate something from that? So let's calculate someone's age. If we can select the first name, comma, last name, we can then run this. What this will do is we'll also pull the age now based on the hire date as age from employees. So we can see the age of John is 3 years old. So not very old at all. In fact, he probably shouldn't be working here. We could do some date arithmetic as well. So if I paste this in and we just run it, let's take a look at what it's doing. It's calculating their next year anniversary. It's adding an interval of 1 year. It's selecting first name and last name and hire date and adding 1 year as next year anniversary from employees. Brilliant. We're done with all the basic queries now. That's pretty much it. There are other things such as common table expressions which are more advanced. Now, these are temporary result sets that can be referenced within a select, insert, update, or delete statement. I'll give you an example here. This is a CTE, a common table expression, to find employees with above average salary. So let's hit run and just see what it does. Here we go. So you can see this is a temporary result which we've created and stored in this output. I don't want to worry too much about it, just to make you aware of it though. There's also things such as window functions. Now, window functions perform calculations across a set of table rows related to the current row. For example, calculating running total of salaries, and that would look like this. We're selecting the first, last name, and salary, and the sum of salary over the date as a running total. equally, a window function can include ranking employees by salary. And to do that, you would do this. You'd select first name, last name, and salary, and rank over an order by descending. So this is assigning them a salary rank based on how great the value of their salary is. Now, joins. A lot of people get quite upset and confused with joins, but actually they're a very crucial part of working with SQL. There are a few different types of joins: inner, outer, left, and right. They are the main key joins. Typically for data analysis tasks, you'll just be using inner. But joins combine rows from two or more tables based on related columns. So this is an image you're going to see time and time again. An inner join is where both of the tables match. Now, when it refers to the left and right table, it just means the order which you type them in. The first table name you type in will be the first or the left table. The second one would be the right. So the left is everything from that first table and where it matches to the right. The right is just reversed, and full is just everything regardless of null or non-matching values. So let's start with an inner join. I want to return the rows with matching values in both tables. So let's join employees and departments. To do that, I'm going to select the first name, last name, and department name. But you'll note this looks a little bit different. Before the column names, I've put a little value here. Now this for me just references which table I'm pulling it from. It just makes it easier for SQL to know, wait a second, what are you talking about? So it's understanding that I'm selecting first name from the employees. So e dot first name. So no, it's employees first name, comma, e dot last name, employees last name, and department name. From employees. Now how does it know that E is employees? Is will I tell it that now? I say the table employees is E. So I want to inner join departments, which I tell it is D, on E.department ID is equal to D.department ID. Both these tables have department IDs, and this is where they match. So it's able to see wherever I find department ID in the employees table, if it has the same value as the department ID in the department table, well, we'll match them up and return the result. Let's give another example. Here I want to do a left join. Now, by default, if you just type join, let's run this here, it will give you an inner join. Just something to bear in mind. But a left join, as we saw, returns all the rows for the left table and the matching rows for the right table. Unmatching rows from the right table will be null. So let's find all employees and their departments, including those without a department. So to do that, you want to type, let's just paste this in here, select employee.firstname. Now for columns, remember it is convention to type the E first. That is how you have to do it per the syntax. Employees first name, employees last name, departments, department name. For tables, you write it after with no dot, just a space. Employees left join. You can see the result here will be a little bit different. Finally, let's return all rows from the right table and the matching rows from the left. Unmatched rows from the left will be null. Here we go. Full outer join, which we also mentioned, will return all rows, whether they're matched or not. It won't matter. There's also something called a cross join. Now, we're not going to worry about that too much now, but it basically would combine, let's do this example here. This would combine every employee with every department. You can see it just extends it down like this, giving you every possible combination. That is a cross join. And all you're doing is from employees cross join departments on those columns. You might come across a self join as well. That's where a table is actually joined with itself, but we're not going to cover that now. What we will cover is multiple joins in a single query. So let's do that here. Let's say we wanted to select the first name and last name from the employees table, the department name from the department table, and the location name from the location table. We're pulling that from employees and then joining them all like this. Now we actually don't have a locations table, but this would be the case if you did have 3 tables. We're joining department on department equals department and location on location is equal to location. What I will cover next is actually modifying your data. So we've looked at how to insert data into a table. Let's say we want to insert into the employees table in the first name, last name, hire date, salary, and department ID, the values. So let's just clean this up a little bit. The values of John for first name, Doe for last name, it picks up the order here. The dates, and then the salary and department. Hitting run will insert it. You can see it ran successfully. You can also insert multiple rows. Now to do that, it would just be like this. So let's clean it up a little bit again, just so it makes sense. We're going to do the first name, comma, last name, comma, hire date, comma, salary and department ID. These values, these are 2 rows. Once that's done, you may want to update your table. So let's update salaries for a specific employee. And to do that, instead of insert, you just type update. So I want to update the employees table to set the salary equal to 65,000, where first name equals John and last name equals Doe. Running that will update. Here you can see that affected 2 rows. What if I wanted to delete from? Well, very simply, I would delete from employees where first name equals John inside quotation marks and last name equals Doe. That then deleted those rows there. Now it is important to bear in mind you can truncate or you can delete. Truncate removes all the rows from a table. It's faster and it uses less system resources. Whereas a delete statement removes rows based on a condition and can be rolled back if used within a transaction. So let's truncate table employees. Here we go. That's removed all rows. So if we now select everything from employees, you can see there's nothing there. If you wanted to delete from employees, so let's say we delete from employees where hire date is less than this, that's how you would run that. It's a lot better way to do it. Now, just to get that data back, let's go to the beginning where I inserted the data into the employees table. So that is here. We're going to insert the data back so that if we select everything once more, we've returned that data. So let's run that same statement again, that same SQL clause, that query, where we are going to be deleting from where hire date is before 2020. Let's run this. And then running again this query, we can see no one is there prior to 2020. Fantastic. So, indexing. Now, indexing is a way to increase the performance of your data. It just means it's quicker to pull for specific columns. But we're not going to focus on that now. Just to bear in mind, indexes will speed up the retrieval of rows by creating a data structure that allows the database to locate those rows more efficiently. Views is something you may want to look into. Now, to create a view, you can probably guess at this point, you just type create view. I'm going to give the view a name. And this view is going to be the first name, last name, and salary, where employees are greater than £60,000 per year. So now we have a view. In fact, if we go down here and refresh, you can see we have this view here that we can reference later. Now, views are very important for different people based on their security rights, their access rights, what they may want to see or pull, especially if they want to pull the same thing frequently. One final advanced topic to cover is advanced functions. Now, one advanced function in SQL or a complex query is the idea, which is stored procedures. Stored procedures are pre-compiled SQL statements stored within a database that can be executed as needed, such as partitioning tables. This divides it into smaller, more manageable pieces. There's also recursive queries. Recursive queries are useful for hierarchical data, such as organizational charts. All of this is going to be in the workbook that we provide on the website. I'm not going to go through that again. What I will go through is some best practices. Write readable code. Use version control with Git, uploading to GitHub. Write documentation in a schema. Write a documentation about the relationships and any business rules. Make sure there are strategies for database refactoring. Regularly review and refactor the database schema to ensure it meets the current needs. Now, if I type in database schema, you can see this is the relationship between all the tables just shown visually. It's important to review this and make sure there's nothing redundant, just so you can meet the most normal form of your data. SQL Zoo is a great place to practice all of this. So let's say we want to go to SQL Basics. We can run through each of these queries. You can see I want to modify this. So you can see the example clause, modify it to be Germany. So we should know very well how to do that now. And I'll get a smiley face. But as you progress through it, it'll start to make you write it out by scratch. It won't just give you the answer, and you'll have to figure it out here. So check this out. All the best and good luck.